What if I told you that right now, time is moving at a measurably different speed for you than for someone standing on a mountain? That is not a philosophical guess. It is a direct consequence of Einstein's theory of relativity, confirmed with atomic clocks. Time is not the constant ticking metronome you imagine. It is a physical dimension, woven into the fabric of space-time. Gravity warps it, speed stretches it. The clock in your basement ticks measurably slower than the clock in your attic. This is where physics gets terrifyingly weird. We already built time crystals that break the fundamental laws of motion. We have mathematical models for traveling backwards in time without tearing causality apart. And neuroscientists have proven your brain lives in the past, constantly assembling a reality that is already 80 milliseconds old. You are not experiencing the present. You are living a beautifully stitched together replay of what just happened. Stick around, because by the end of this video, you will never look at a clock the same way again. Einstein again, yes, but stick with me. Your watch ticks at a constant rate, a steady, reliable beat. That is a lie. Time is not a steady flow. Think of it as a rubber sheet, stretch it out flat. Now drop a bowling ball in the middle. The sheet curves. That curve is gravity warping time around the ball. The closer you get to the ball, the more stretched time becomes. This isn't abstract math, it's been measured. GPS satellites orbit at a higher gravitational potential than you, so their clocks tick faster. Engineers have to subtract 38 microseconds per day, otherwise your map pin would drift kilometers by lunch. So time bends. But your personal experience of time is an even bigger illusion. You think you live in the now. You don't. When your eyes see a flash, that information takes time to travel to your brain. Your brain then collects fragments from different senses, synchronizes them, and constructs a single present moment, about 100 milliseconds after the events occurred. This is called the specious present. You are always living a tiny slice of the past that feels like now. Reality is delayed. Your brain just hides the lag. Here's where the illusion gets cultural. It turns out language programs how you expect time to behave. Mandarin speakers think of time vertically. The past is up, the future is down. Greek speakers think of time in 3 dimensions, not one. The way you describe time changes how you instinctively imagine its shape. Which means your subjective experience of time is not universal. It's learned, so your watch is wrong, your brain is slow, and your language is twisting the timeline. We haven't even touched the part where time crystals break the rules entirely, but that's coming. So you know time bends, but did you know it also stretches and compresses based on speed? That's time dilation, and it might be the most useful weird property in the universe. Here's the classic twin paradox. One twin blasts off at near light speed. When she returns, her twin on Earth is decades older. Her watch ticked slower. Her cells aged slower. Everything slowed. This isn't fantasy. It's a direct consequence of Einstein's equations. But we don't need hypotheticals. In 1971, Haefel and Keating flew atomic clocks around the world on commercial jets. Eastbound clocks returned having lost time compared to ground clocks. Westbound clocks gained time, exactly as predicted. Then there are muons, 2 microseconds, 5% light speed. Their internal time is dilated by a factor of 10. Our own sky is a time dilation laboratory. This isn't just particle physics. 1 second less per year compared to Earth. Small, but measurable. Now, if time slows down for fast movers, it means you could theoretically jump to the future. Fly a ship near light speed, return, and Earth has aged centuries. That's allowed by physics. The catch, you need insane energy. But traveling to the past, that's a completely different can of worms. We'll open that one next. If you could time dilate into the future, what year would you pick? Drop it in the comments. And hit like unless you're from a timeline where that button doesn't exist. So forward time travel isn't just possible, it's mandatory. Every second you move, you're slipping into the future. The only variable is how fast. In 2015, astronaut Scott Kelly spent 340 days on the International Space Station. When he returned, his identical twin Mark was 5 milliseconds older, measurably older. Scott's cells aged slower, his watch ticked slower, his entire timeline lagged behind. That's not a metaphor. That's a 5 millisecond round-trip ticket to the future. Now multiply that. Constant 1g acceleration, the same force pushing you into your chair right now, could carry you across the entire Milky Way in just over a decade of your time. When you stepped out, Earth would be tens of thousands of years in the future. You'd have outrun your own century. That's forward time travel on a cosmic scale. Forward is simple. The universe practically forces it on you, the hard part. Reversing direction, because traveling backward means breaking causality itself, and that's a whole different kind of weird. Coming up next. Backward time travel, that's where the universe stops being a train schedule and starts being a logic puzzle with a headache on the side. Start with the classic grandfather paradox. Go back, eliminate your grandparent, vanish yourself. Problem: if you never existed, who pulled the trigger? It's a contradiction so clean it feels like a trick. Then there's the bootstrap paradox. Object appears from nowhere. Someone finds it, invents it, gives it to themselves. Where did the idea originate? Nowhere. It always existed in its own loop. That's not just weird, that's logically radioactive. Predestination paradox flips it again. You travel back to stop a disaster and end up causing it. Your actions become the reason the disaster happens. You fulfill history instead of changing it. Physicist Igor Novikov proposed a solution: self-consistency. Time travel is allowed, but only if your actions were already part of history. You can't change the past because you already failed to. In 1991, he demonstrated this with Polchinski's billiard ball, a ball that rolls back in time and bumps its younger self exactly enough to cause its own time travel. No paradox. Stephen Hawking tested it practically. He threw a party for time travelers, but didn't announce it until after. No one showed. That's either proof time machines don't exist, or proof time travelers have better things to do. But here's the kicker: the math still leaves a door open. And the weirdest part, that door might actually lead somewhere, if your brain isn't twisted enough. Like and subscribe before you forget to in the future. But before you start shopping for a DeLorean, here's the problem. Time has a preferred direction, and it's not backward. You can't unscramble an egg, unburn toast, or unsay that awkward thing at dinner. That's the thermodynamic arrow of time, and it's the reason you age. It's all about entropy, a measure of disorder. The second law of thermodynamics says entropy in a closed system always increases. Not because a cosmic policeman enforces it, but because it's statistically inevitable. There are astronomically more ways for things to be messy than tidy. Drop an ice cube in hot coffee, it melts. You will never see the coffee boil while the ice cube grows. The odds are effectively zero. The classic image, a drop of ink in water. It disperses, spreading evenly. No amount of stirring will force it back into a droplet. The universe is that ink drop on a cosmic scale, mixing order into chaos. But here's the real mind-bender. If entropy always increases, the past must have been incredibly ordered. And it was. The Big Bang started everything in a state of absurdly low entropy, a smooth, hot, uniform soup. Why, we don't know. But if the universe began in equilibrium, entropy wouldn't change, time would have no arrow, nothing would happen. You wouldn't exist, so your very existence depends on that low entropy starting point. And the arrow it created points relentlessly forward toward maximum disorder, the terrifying end point, heat death. A universe where every star has burned out, every particle is the same temperature, and nothing interesting ever happens again. Still, that's billions of years away, so go ahead, make a mess. The universe is doing it anyway. The universe has a rule: everything runs down, every clock winds down, every star burns out. The second law is non-negotiable. But then someone found a phase of matter that clearly didn't get the memo. Meet the time crystal. A regular crystal repeats its atomic structure in space. A time crystal repeats its atomic structure in space and time. It oscillates, flipping between configurations in a perpetual fixed rhythm, never losing energy. Forever, like a pendulum that swings without friction, but more radical. It's not converting any energy into motion. It's already at its lowest energy state. It just ticks. That sounds like magic or a violation of physics. The loophole: time crystals are stable in their ground state. They're not extracting work, they're exhibiting spontaneous periodic motion built into their quantum structure. Think of a pendulum that swings without ever being pushed because swinging is the minimum energy state. You can't create one in your garage, but in 2012, Nobel laureate Frank Wilczek predicted them, and by 2022 researchers had built the most robust time crystal yet, using a chain of ions and laser pulses. They coupled it to a mechanical resonator, a tiny vibrating beam, to confirm the oscillations were real. The resonator synced with the crystal's beat, proving this wasn't a fluke but a new reality. Why should you care? Because time crystals could become hyper-accurate quantum sensors, or components in computers that process across time. They show us that time isn't just a stage for physics, it's a variable you can build into matter itself. But wait, if a crystal can tick forever, what else can time do? Quantum physics is about to get even weirder. Like and subscribe before your own timeline branches. But here's where physics gets even dirtier. The universe is biased. It prefers left over right, matter over antimatter, and apparently forward time over backward. That's not an opinion, it's measured. The weak nuclear force only shakes hands with left-handed particles. Right-handed ones get ignored. Parity symmetry, broken. Swap particles for antiparticles. Charge symmetry, also broken. Combine them into CP symmetry, and even that fails. In 2012, the bar experiment at SLAC watched neutral B mesons decay. The odds of a particle flipping to its antiparticle simply were not the same as the reverse reaction. The universe knows which way the arrow points. Now for the time reversal trick. The exact same experiments showed that running the reaction backwards gives different probabilities. T-symmetry is broken at the fundamental level. The equations of particle physics are not time reversal invariant. You can tell a tape is being rewound just by looking at a single B meson decay. So how can we ever trust the laws to be consistent? Enter the CPT theorem. This says that if you flip charge, swap parity, and reverse time all at once, the physics must be identical. Even though each symmetry can break on its own, the triple combination is sacred, a mathematical requirement of combining quantum mechanics with special relativity. Experiments confirm it to better than 1 part in a billion. What does that mean for your DeLorean? To reverse time alone, you'd also have to reverse every particle's charge and mirror its spatial coordinates. You'd become your own antimatter mirror twin, not exactly a road trip. But black holes might not obey these gentlemanly rules. At the singularity, space-time curvature becomes infinite, and our theorems break. They could be the universe's cheat codes for time travel. If you want a one-way ticket to the future, hit subscribe. Your present self will thank you. You want to break time? Drop a clock near a black hole. From your safe orbit, the clock ticks slower and slower, effectively freezing at the event horizon. It never crosses. From your perspective, time is arrested at the boundary. But if you jumped in, your wristwatch would tick normally. Instead, the universe outside ages at warp speed. You could watch the cosmos die in what feels like minutes. The downside, you become a human noodle first. So black holes stretch future time. To visit the past, you need closed time-like curves. General relativity draws them like a drunk cartoonist. Paths that loop spacetime so you shake hands with your younger self. The math allows it. The universe, however, slaps the pencil away. To stabilize such a loop, you need exotic matter with negative energy. The Casimir effect gives us a sliver of it between metal plates. But scaling that to a time machine requires a negative energy mass equal to half a galaxy. No deals, wormholes are theoretically possible, but they're the Manhattan real estate of physics. Great on paper, impossibly expensive. And here's the final kicker: all time must end. The universe runs down, black holes evaporate. Before they vanish, they might scramble causality into a pretzel, but you won't be around to see it, so subscribe quickly. Time is literally running out. Every second, the universe gets a little more bored. The universe doesn't end with a bang or a rip. It fades into a quiet, eternal indifference. This is heat death, maximum entropy. Every star burned out, every black hole evaporated, every particle isolated beyond interaction. No free energy, no gradients, no change. The universe reaches complete equilibrium, a lukewarm bath of photons and leptons, slowly decaying into nothing. When? Prepare for a number that mocks human scale. 10-100 years, that's a 1 with 100 zeros. By then, every proton might have decayed, every black hole radiated away, every orbit dampened into stillness. The universe becomes a uniform soup at a temperature near absolute zero, and it stays that way forever. Philosophically, time loses its meaning. The arrow of time is tied to entropy. In a maximum entropy state, there's no increase, no direction. Does time still march forward? Your watch would tick, but without change to measure, the concept becomes hollow. Some physicists argue time emerges from quantum entanglement. In a static equilibrium, entanglement is minimal. Time might simply dissolve as a useful description, but this is the finale, not the current episode. You exist in a universe that is still active, still interesting, still producing new structures. Entropy is low, energy is abundant, and time has a clear arrow. So until the heat death arrives, we have this incredible, weird time to explore. Make the most of every tick before the clock stops being a clock. Time slows near black holes, tangles in paradoxes, ticks in time crystals, and fades into heat death. It's the weirdest phenomenon in the universe, but you're swimming in it right now. That present moment you keep ignoring. It's a low entropy miracle. Appreciate that. Next time you glance at a clock, remember, each second is a tiny rebellion against cosmic boredom. If you enjoyed bending your mind about time, hit that like button, but only if you're doing it in the present moment. And for more brain-breaking physics, check out our playlist on quantum weirdness. Thanks for watching.